So today we are looking at limit. And before we delve into the concept of limits, I would want us to start with something that we are much familiar with. So the first problem of the day is that for each sequence, we want to determine its limit and rewrite the sequence in the form x approaches a to the power minus or x approaches a to the power plus. But what does this minus and plus mean? We'll talk about that as we move along. Now, when we look at the sequence 2.24, 2.249, 2.2499, 2.24999. It appears this sequence or these numbers in the sequence are approaching certain value. What can we say? Just think of it for a second. What value are they approaching? When we look at it, these numbers are approaching the limit 2.25. Now, since each number in the sequence is less than 2.25, you write x approaches the number 2.25. Now, is it to the power minus or to the... Now, this is where I would want us to, start our discussion from. Now, we claim that since all these numbers in the sequence are less than 2.25, it just means that x is approaching such value from the left. Let me take it again. Since all these numbers in the sequence, which is 2.2, 2.24, 2.249, 2.24999, and 2.24999 are approaching 2.25. And these same numbers in the sequence are less than 2.25. We claim that x is approaching the number 2.25 from the left. All right. So I believe we all understand it. Good. All right. So how do we read this? We read this as x approaches 2.25 from the left, 2.25 to the power negative 1. Or to the power negative means that the x is approaching 2.25 from the left. If it is to the power plus, it just means that to the right. So let's take note. Thank you. So let's look at the second problem. So when we look at the second problem, what can we say? It appears that the first number in the sequence is 5.51. But as time goes on, you realize that this number is decreasing towards a certain value. What value is that? Think of it. What value is it decreasing towards? Just 5.5. Good. It's 5.5. So since it is decreasing towards 5.5, we can write it as x approaches 5.5, it is to the power plus. We say plus because since all these numbers in the sequence, which is 5.51, 5.501, 5.5001, and 5.50001 are greater than 5.5. So it means that x is approaching this particular value, which is 5.5, from the right. So x approaches 5.5 from the right. Good. All right. So our second problem, we have f of x equal to x squared minus 9, all divided by x minus 3. Now, the first question says that what is the function value with 3 as the input? So what do we do? So for the A part, what it just means is that wherever we see x, just replace it by 3. In that case, we're going to have x squared minus 9, all divided by 3 minus 3, in which case we're going to have 0 over 0. So what can we say? The function value does not exist. Now, let's look at the B part. It says that what is the limit of the function as x approaches 3? Now, this is a very interesting question. It just more or less like a follow-up question to the first problem we solved. Now we learned about x approaches a from the left, so we can apply that same notion here. In the first instance, we claim that when x is approaching a from the right, what it means is that there are certain values of x that are greater than a. Conversely, if x is approaching a from the left, it means that there are certain values of x that are lesser than a, All right. So let's pick some values that are lesser than 3. Good. We have 2.5. Nice. Good. Nice examples. So 2.9, 2.99, and then what? Let's pick 2.999. These are nice examples. Do some computation. So let's pick the first value and plug it into the main function. Remember that the main function is x to the power 2 minus 9, all divided by x minus 3, right? Now, when x is 2, Then we plug into the main function. So we have 2 to the power 2 minus 9 divided by 2 minus 3. And that gives us what? It gives us 5. So it means that over here, we're going to have 5. When s is 2.5, you're going to have 2.5 to the power 2 minus 9 over 2.5 minus 3. So when we do the computation, we are going to have 5.5. Now, when you continue with your calculation, you should have values as 5.5, 5.9, 5.99, 5.999. Now, when you look at this, what can we say? Over here, we claim that these values are approaching a certain number. They approach a certain limit. And what number is that? What can we say? It appears that limit of the function as x approaches 3 from the left side is 6. Very good. It's 6 because we have, when we plug in the x values, we had first value, we had 5. Subsequent one, we had 5.5, 5.9, 5.99. So as x approaches 3 from the right. So we're also going to build a table. As I said, when we say x is approaching 3 from the from the right, what it means is that those values should be greater than 3. Let me repeat myself. If I say x is approaching 3 from the right, what it means, there are a set of values that are greater than 3. Very good, thank you. All right, so when we do the same thing, when you do the same computation, we should get something like 7, 6.5, 6.1, 6.01, 6.001. What can we say of the function as x approaching 3 from the right is what? 6. Now, we claim that this implies that the limit of the function as x approaches 3 from the left is equal to the limit as x approaches 3 from the right. This result is very interesting.